talking about normal probability curve yesterday, so I'm going to continue with that. So normal probability curve, which has already been defined in the last class and whose probability density function is in front of you on the screen, as you can see it. uh, this was the expression of the PDF when capital X is the normal variable. And also I told you in the last class that capital X, the normal variable, has two parameters. One is the mean of the normal variable and another is called the standard deviation of the normal variable. Normal curve is a bell-shaped curve and it is symmetric about the mean, and one of its important properties is the mean, median and mode of normal curves, uh, where mean, median, mode, these are actually measures of central tendency. They coincide at single point. And since mu is the mean, so, and since it is median also, so it divides the normal curve into two equal halves. So along the point 2, I can draw a vertical line, and we can say that on the left hand side of that line, 50% of the left hand side of the line covers 50% of the area, right hand side of the line covers 50% of the area, so that the total area is 1. And also I told you, with respect to the values of the standard deviations, we can get a normal curve which is spiked, which is moderate, and which is flat. These spiked and this moderate normal curves and these flat normal curves, and these characteristics can also be measured, which we shall be learning in the module 2 of our syllabus. If the normal curve is, whether a particular curve like this is spiked or flat, it is actually measured with the help of a mathematical tool known as kurtosis. And we are going to learn kurtosis in the module 4 of our syllabus of basic statistics. And also I discussed about standard normal curve, standard normal variable, which is defined in the following way. And if we consider this expression of the standard normal variable, its probability density function is taking this particular form: 1 by root over 2 pi integration from minus infinity to plus infinity to the power minus z square by 2 dz. I explained this to you. And lastly, before I could conclude my studies class, I talked about this. Today, before the class started, I actually modified the expression a little bit. I introduced this particular section so that you can understand when we transform the variable x to variable z, and we are going to calculate the probability that z takes the value from -1 to +1. This probability is nothing but the calculation of the integration from -1 to +1, integration of the integrating factor, integrand 1 by root 2 pi to the power minus z square by 2 dz. And if we integrate this, the probability will come, the value will come out to be 0.68. Similarly, if we talk about the probability that z takes values from -2 to +2, then that means we are going to calculate the integration. We are going to solve the integration from -2 to +2 for the integrand this, and the result comes out to be 0.95. And similarly, if z takes values from -3 to +3, the probability, or you can consider the area under the normal curve from -3 to +3 will be 0.997, or you can say that 99.7% of the total area will be covered by this region, -3 to +3. Also, I talked about 6 sigma structure, where I said that if we consider a normal curve, then from -3 to +3, total distance is 6, and that is called 6 sigma length. 6 sigma is very important in statistics, which has been discussed yesterday with you. Okay. And these integrations, I told you that these integrations are actually improper integrations. Okay, improper integrals. So we cannot solve them analytically, and to solve these integrations, we have to take the help of numerical integrations. Some of the techniques of numerical integrations are trapezoidal rule, Simpson's 1/3 rule, and Gödel's rule. And in this semester, these topics are there in your syllabus. So whoever is teaching that particular subject, you ask the teacher to show you how to apply this numerical integration rule to calculate these areas. Okay, these areas can be found. Okay, this is very interesting problem in numerical analysis. And if you ask me whether you are supposed to learn or memorize these probabilities or not, my answer would be yes, because these areas, that is from -1 to +1 and -2 to +2, these areas are actually standard areas. Okay, and you have to memorize these standard areas. So if I ask you at any point of time what is the area that Z takes values between -2 to +2, immediately you have to reply that it should be 0.95. These areas, nobody takes help from the chart. Okay, every statistician tries to memorize these three areas. Okay, so you practice, and when you will be solving problems, okay, so the more problem you solve, the more will be practiced, and it will be much better for you to memorize these three probabilities. But these are not the only probabilities. These values of Z are not the only values. Okay, we can have some other values also. So for those values, you don't have to memorize any probability, and in that case, we take the help of the statistical table, which I'm going to show you, present you right now. This is the statistical table which I was about to talk in my last class. This is called the standard normal table. So what happens here is that you see on the leftmost corner, leftmost row, some values of X are given from 0.0 to 3.4, and on the uppermost row some values are given, you see, from 0.00 to 0.09. And what is this table all about? It gives you the probability that capital Z takes a value lesser than small x. Now suppose I am interested in finding that what is the probability that capital Z is less than, say, 0.11. Okay, so in that case, I mean to put 0.11 in place of x. Okay, 0.11 in place of x. Now let's take the help from the chart. Go to this part, 0.1. Okay, and move your observation to the right. Go and come to this point. Okay, this point corresponds to 0.01. This point, 0.5438, corresponds to 0.1 and 0.01. If I add these two figures, 0.1 and 0.01, we get 0.11. So probability that capital Z takes value less than 0.11 is, this probability is calculated as 0.5438. Okay, can we calculate this with the help of numerical integration? Obviously, yes, we can calculate this. We will have to integrate from -infinity to 0.11. Okay, but computer will not understand -infinity, so we actually calculate the probability from -0.11 to +0.11 with the same techniques of trapezoidal rule, Simpson's 1/3 rule, and Gödel's rule. So I will suggest all of you, whenever we will be learning this trapezoidal, Simpson's 1/3 and Gödel's rule, okay, then you take this PDF of the standard normal variable and you try to generate the standard normal probabilities by yourself. You will find it very interesting. Here I am going to explain 4 easy problems for you, and I will keep these remaining problems for you to practice. Okay, now let us find the solution of these problems. Suppose now it would be much better, before I continue with this problem, if you keep a copy and a pencil in front of you so that you can practice or you can verify what I am saying. Okay, so carefully listen. I am going to solve these 4 problems for you, and the remaining 5 problems will be kept for your practice purpose. I am going to find the probability. What is the probability that Z greater than -1? Okay, some options are given. 4 options are given over here. I am going to select the correct option. For this, I have drawn this curve. Okay, this curve has been drawn to solve problem number 4. And you see, since I am interested about the point -1, so in the curve, we have denoted the point -1 on the left hand side and +1 on the right hand side. Okay. Now you see, probability of z greater than -1 signifies this area, entire right hand side of -1. Okay, I hope you can see, all of you can see. Entire right hand side is being signified, is being represented by this z greater than -1. Since 1 is equidistant from 0, this is the middle point, this is 0. Okay, since 1 is equidistant from 0, as -1 is, so z greater than -1 will be same as z less than -1. So right hand side, the entire right hand side of -1 will be same as entire left hand side of +1, because normal curve is symmetric. So probability of z greater than -1 is actually becoming what? Probability of z less than +1. So we are getting probability of z less than +1 here in place of probability of z greater than -1. You note it down. Now probability of z less than +1 can be done in 2 ways. Either you take the help from the normal chart. Let us take the help from the normal chart first of all. So we are supposed to find probability that z less than +1. What we are going to do is that we will go to the normal chart and we will try to identify the point 1. That is the point 1.0. And 1.0 plus 0.00 gives you 1.0. It doesn't change. So probability of z less than 1 has the probability 0.8413. Okay. So probability of z less than 1 is 0.84. So this is the right answer. And since probability of z less than 1 is same as probability of z greater than -1, so it has got the probability 0.84. This is one way. This is one way. Another way, you see, you write in your copy, probability of z less than 1 can be broken into 2 halves. What are they? Probability of z less than 1 can be written as probability that z takes values from 0 to 1, this area, plus this entire area on the left hand side of origin. Now this entire area of the left hand side of origin is 0.5 because total area is 1. So it is 0.5, right? And if we can find this area, we can add this area with 0.5 to see whether 0.84 is coming or not. Now standard area law will be applicable here. You see, we know from our above results that z takes values from -1 to +1 has the area 0.68. So this area is 0.68. And since 0 is the middle point, okay, so the probability that z takes values from 0 to 1 will be the half of the total area from -1 to +1. So we are going to divide 0.68 by 2, which will be 0.34. Now you multiply, now you add 0.34 with 0.5, and you are going to get 0.84. 0.5 plus 0.34 is 0.84. So again we are getting this area for the probability that z greater than -1. Okay, so that is the alternative way by which we can calculate the probability. Either you take the help from the normal chart or you can do this simple calculation. Okay, let us now try to find the area of this or the probability of this. The probability z greater than 1. So for this I am considering this figure. This figure corresponds to problem number 5. Okay, so these problems are 4, 5 and 6, 7 because I have actually taken the image from a book, and there the problem numbers were like this. So this is, you can consider this to be my second problem, but according to that book it was the problem number 5. So don't get confused. Now I'm considering this particular figure. Probability of z greater than 1. Z greater than 1 means the entire right hand side of 1. And from the complementary probability law, we know that probability that z greater than 1 will be similar to 1 minus probability that z less than 1. Okay, probability of z greater than 1 will be 1 minus probability that z less than 1. But we have already calculated the probability of z less than 1, which is 0.84. So 1 minus 0.84 will give you 0.16. So the answer is 0.16. Okay, let us go to the next problem. Problem number 6. Here I am interested in calculating probability of z greater than 3. So the entire right hand side will be taken into consideration, the entire right hand side of the point 3. Since just like our previous problem, probability of z greater than 3 is same as 1 minus probability z less than 3. So again you can consider the standard normal table. Let us go to the point 3.0. 3.0 plus 0.00 gives you this probability, 0.9987. Okay, so I am going to subtract 0.9987 from 1. I am going to subtract 0.9987 from 1, and you will get the result, say 0.000 something. Okay, here you see the 4 options. One option is 0.3, another option is 0.05, another option is 0.99. If you subtract 0.9987 from 1, you will see that the answer is approximately equal to 0. So here the correct option will be 0. And lastly, if we talk about probability that point z is less than 2, that this can again be done in 2 ways, either directly from the chart. Okay, so if we consider if you take the help of the chart, you see, let us mark the point 2 here, and you see the probability is 0.9772. So here the answer will be approximately 0.97. Okay, or you can calculate the probability that z lies between 0 and 2. This probability can be calculated, and that will be added with 0.5, this portion. Probability that z lies between 0 to 2 can be easily calculated, because from the standard probability law, z lies between -2 to +2, its probability is 0.95. So probability that z lies between 0 and 2 will be half of 0.95, and you are going to get this probability, and you add this probability with 0.5, and you will get approximately 0.975. So what I am saying, because it is not possible for me to type or to press cursor and move the cursor to draw the figures, because I am not using tab, I am using my laptop. So I am very much disappointed to actually, I'm disappointed that I am unable to show the calculation to you. Okay, but you don't be upset. You do the calculation by yourself. Probably you have understood. I'm going to show you. I'm going to scroll down. I'm going to show you some more problems so that the idea becomes clear to you. But you try these 4 problems and verify whether I have correctly done it or not. Okay, and once you finish it after the class, you practice these 5 problems, and you will definitely understand what is happening and how to calculate. You will feel comfortable with normal probability. So let us now go to the next problem, okay, which I have typed in here. Okay, so it will be much easier to make you understand. The problem is, this is my question 1. Okay, suppose the amount of time of a light bulb works before burning out is a normal random variable with mean 400 hours and standard deviation 40 hours. If an individual purchases 2 such bulbs, one of which will be used as a spare to replace the other, when it burns out, what is the probability that the total life of the bulbs will exceed 750 hours? Here you can ask me this question, how am I sure that the lifetime of the light bulbs will be normal random variable? I'm not going to explain this particular part right now. Rather, when I shall be doing hypothesis testing, this answer will be given to you. How do I know that a particular random variable is actually binomial or Poisson? You know binomial and Poisson. How do you know that a particular random variable is normal? Okay, for the time being, and for the sake of the understanding of the calculation, let us uh, let us hold what is given in the question to be true. Okay, that the average lifetime of the light bulbs is indeed normal. Now, therefore, we have actually defined a random variable capital X, which denotes the lifetime of the light bulb, and we have assumed another random variable capital Y, which also represents the average life of the light bulbs. And I have considered two different random variables of the same nature because we are actually considering two light bulbs here. Okay, each light bulb's average life is 400 hours, and standard deviation is 40 hours. Now, according to this information, expectation of X is 400, expectation of Y is also 400. Standard deviation of X is 40, standard deviation of Y is also 40. What am I supposed to find? I am supposed to find what is the probability that the total life of the bulbs will exceed 750 hours. So the total life of the light bulbs will be represented by the random variable X plus Y. And I'm supposed to find the probability that X plus Y takes values greater than 750. In this type of calculations, the units doesn't actually count. Okay, units are not important. What is important is the value only. Now, since my random variable has become X plus Y, and I told you in my last class that all the calculations in normal probability law will be on the basis of the standard normal variable, because we have the standard normal variable chart in front of us. So we have to transform this variable X plus Y to its corresponding standard normal form. Okay, what is the formula for the standard normal variate? If capital X is the normal variate, the formula is X minus mu by sigma, and that becomes Z. Z is the standard normal variate. Now, in this case, my normal variate is X plus Y. So I am going to subtract the mean from this, and I'm going to divide the difference by the standard deviation. But the mean of what? Do I have to subtract the mean of X or mean of Y? The answer is no. Neither I am going to subtract mean of X or mean of Y. I am going to subtract mean of X plus Y, and I am going to divide the difference by the standard deviation of X plus Y. Because X plus Y is my normal random variable, not X and Y. So we shall be using this additive property of the normal random variable, which is very simple. You already know it. The additive property says that if capital X and capital Y are two random variables which are normal and which are independent also, where capital X has the expectation mu and Y has the expectation eta, then capital X plus Y is also a normal random variable, and its expectation will be expectation of X plus Y, which is, you already know, expectation of X plus expectation of Y by the property of expectation, and it becomes mu plus eta. Similarly, since X has the standard deviation sigma and Y has the standard deviation tau, so variance of X is sigma square, variance of Y is tau square. Since capital X and Y are independent, variance of X plus Y will be variance of X plus variance of Y. Variance of X will be sigma square, variance of Y will be tau square. So variance of X plus Y will be sigma square plus tau square. And since standard deviation of x is the positive square root of the variance, so standard deviation of x plus y will be root over sigma square plus tau square. This is called the additive property of the normal random variable. I am now going to subtract the expectation of x plus y, which is 400 plus 400, from x plus y, and I am going to divide this difference by the standard error of x plus y, which is root over 40 square plus 40 square. Okay? The same calculation will be repeated on the right hand side also. The same calculation will be repeated on the right hand side. So right hand side becomes 750 minus 800 by root over 40 square plus 40 square, that is twice 40 square. If we do this calculation, we will be getting probability that z takes values greater than minus 0.8838, because the left hand side takes the form of x minus mu by sigma, and therefore it is standard normal variable, which is z, which can be represented by z. So it becomes z on the left hand side. On the right hand side, I am getting minus 0.8838. Let us now draw the normal curve. I am interested about this point, minus 88, minus 0.88. Okay, this is the curve. This is the point I am interested with. So I have put this point over here, minus 0.88. And since the normal curve is bell-shaped, plus 0.88 has been shown on the right hand side also. Okay. Now you see, if I am supposed to find the probability that z takes values greater than minus 0.88, just like my previous problem, probability of z greater than minus 0.88 is same as probability that z less than plus 0.88. Okay, this entire right hand side is equal to the entire left hand side of 0.88. So probability of z greater than minus 0.8838 is similar with probability of z less than plus 0.88. Let us go to the standard normal curve. Let us choose the point 0.8 here. 0.8 is shown. Okay, and you move on the right hand side, you will find that 0.88 plus 0.08 will give you 0.88, and the probability is 0.8106. The probability is 0.8106. So it becomes approximately equal to 0.81. The probability that z greater than minus 0.8838 becomes 0.81. Okay, which is similar to probability that capital X plus Y greater than 70, which signifies that there is 81% chance that total lives of the two bulbs will exceed 750 hours. My next problem is about this one, which is shown in question number 2. Question number 2 says, data from the US Department of Agriculture indicate that the annual amount of apples eaten by randomly chosen women is normally distributed with mean 19.9 pounds and a standard deviation of 3.2 pounds, while the amount eaten by a randomly chosen man is normally distributed with a mean of 20.7 pounds and standard deviation of 3.4 pounds. Suppose a man and a woman are randomly chosen. What is the probability that the woman ate greater amount of apples than a man? Now this problem is not a silly problem in the sense every statistical problem has something behind the screen which has not been expressed over here. Here the problem has been set in front of you, and your technicalities with your efficiency with the normal random variable to deal with the normal random variable is being checked. But what is the logic behind this type of problem? Problem is, suppose women have some kind of health advantage over men, and maybe this is because apples, some people believe. So that statistics is being judged, and therefore this problem is in front of you. Here also I am going to select two random variables, x and y, where x signifies the amount of apple eaten by the men and capital Y the amount of apple eaten by women. Okay, and since it is given on the last line that we are supposed to find the probability that women ate greater amount of apples than men, that means we are interested in finding the probability that y is greater than x. which is similar to probability of x minus y is less than 0. Now you look at this particular question. Since capital X denotes the amount of apples eaten by average, the amount of apple eaten by men, its average is given by 20.7 and its standard deviation is given by 3.4. Similarly for Y, the average is given to be 9.9 and its standard deviation is given to be 3.2. So the expectation of X is 20.7, expected standard deviation of X is 3.4, expectation of Y is 19.9 and expectation of standard deviation of Y is 3.2. Since my variable, my random variable here is X minus Y, to transform this random variable into its standard normal form, I am going to subtract expectation of X minus Y from X minus Y. So I am going to calculate that. Expectation of X minus Y by the rule of expectation will be expectation of X minus expectation of Y, which is 20.7 minus 19.9 gives you 0.8. And standard deviation of X minus Y will be root over 3.4 squared plus 3.2 squared. Where plus sign is there? Because you know variance of X minus Y, where X and Y are independent, is variance of X plus variance of Y. It is not variance of X minus variance of Y. So standard deviation of X minus Y, there will be plus sign, not minus sign. Okay? And the result comes out to be 4.669. Now if I denote my variable X minus Y by W, okay, then my problem actually takes the following form. It becomes probability that Y is greater than X is similar to probability of X minus Y less than 0, which is equal to probability of that W is less than 0. Now I am going to subtract this mean from both sides. I am getting probability of W minus 0.8 less than 0 minus 0.8, and I'm going to divide both the sides by this positive value 4.669. So there, since it is positive, so there will be no change in the sign. So my left hand side becomes Z and my right hand side becomes minus 0.17. And if I draw the normal curve once again like this, you see probability of this particular side appearing on the left of minus 0.17 is similar to the side corresponds to right hand side of plus 0.17. So I have written here probability that Z greater than 0.17. And probability that Z greater than 1.17 is equivalent to 1 minus probability that Z less than 0.17. So again, you take the help of the normal chart from above, you will find this probability from the normal table, 0.5675. So we are going to subtract this probability from 1, and this is your required answer, 0.4325. So the probability 4325, with this particular probability, the randomly chosen woman would have eaten a greater amount of apples than randomly chosen men, which means that approximately 43% of women have some kind of health benefits over men in United States of America due to the apple eating. Let me show you the last problem of today's class, which is this, which is also very simple. The problem says that the activation pressure of a valve produced by a certain company is a normal random variable with expected value 26 pounds and per square and standard deviation 4 pounds per square inch. What percentage of the valves produced by this company has activation pressure 20 and 32 pounds square inch? So here capital X, the random variable, denotes the activation pressure, and its expectation is given as 2 in 26, and its standard deviation is given to be how much? 4. So I have written here Ex equal to 26 and standard deviation of X equal to 4. I am supposed to find the probability that X lies between 20 and 32. So I have shown it over here. Probability that X lies between 20 and 32. I am going to subtract the mean of the random variable from all the sides, and I'm going to divide the difference by the positive standard deviation on all the sides. So I'm getting this 20 minus 26 by 4 x minus 26 by 4, 32 minus 26 by 4, and this middle value becomes z, because x minus mu by sigma is z, and these extreme ends become minus 0.15 to plus 0.15, which I have shown in the following figure. Now, probability that z lies between these particular values, minus 0.15 and plus 0.15, this can be calculated if we are going to subtract probability of this part plus probability of this part from total probability. Ignore this particular portion. This portion came because I wanted to highlight this picture. So this thing came. It is not the axis. Remember, don't confuse it as axis. So probability of this part will be the total of these portions, this portion and that portion, which will be subtracted from total probability, which is 1. So we have written 1 minus probability that z less than minus 0.15 minus 1.5 and plus probability that z greater than plus 1.5, which is equal to 1 minus. Now probability that z less than minus 1.5 is similar to this area, because they are symmetric. Normal curve is symmetric. So z less than minus 1.5 has been replaced by this, z greater than plus 1.5. So therefore we have ultimately got 1 minus twice probability z greater than 1.5. And probability of z greater than 1.5 is 1 minus this. And from normal chart we can calculate this probability, and we are substituting it, and ultimately we are getting the probability 0.8664. Okay, so that's how we do the normal probability calculations. Here is a practice problem for you, which you practice tonight. I'm going to upload this video and the note in the Google Classroom, and tomorrow we are going to meet again in our scheduled time. So till then, tata.